Welcome back, guys. Again, we are having a new lecture for biomolecule. In the biomolecule series, it is lecture number 11, and in the case of protein, it is the lecture number 3. For protein, it is the lecture number 3. Already, two lecture for the protein is uploaded on the channel. You can go through it and check it. Okay. So this side, your chemistry faculty, Govind sir. I think till today you people are aware about my name, and we are here in our beautiful chemistry channel, Chemistry Guru 1993. So that's all about the introduction. So again, till the last video, we have discussed about the polypeptide, right? Uh, in the case of polypeptide, we have discussed about um, protein. I hope that was clear to you. Now come to the what is protein. Come to the definition of protein. Okay. So what is protein, children? So protein is a polypeptide, more than 100 amino acid residue. 100 amino acid residue with molar mass greater than 10,000 AMU, that also denoted by capital D, is called protein. So in the protein we are having 100 amino acid, more than 100 amino acid with molar mass more than 10,000 AMU. So protein's molar mass is greater than 10 kd. Okay. One exception case is there. That is the only exception in the case of protein, insulin. Insulin has only 51 amino acid residue. So that is the exceptional case, guys. Insulin is having only 51 amino acid residue, even though it is a protein. Okay. So if we are talking about the molecular shape of protein, so this is the definition only. You can take a screenshot. Molecular shape of protein what is the molecular shape? So here two types. Here we are going to discuss the two types. Two types of classification we are going to discuss. One is fibrous and second one is globular. So what is the basic difference in these two that we will discuss? In the case of molecule, children, fibrous molecule is long and thin. just like female's hair. It's a long hair and thin. So this is the fibrous structure. Globular, if we are talking, so it is fold into spherical 3D shape. Fold into spherical 3D shape. Examples, if we are talking, so keratin, you know, children, very famous thing, very famous protein that is responsible for the oh, that is responsible for the hair. Keratin in hair and in fingernails also. And second is collagen, where it is found in skin and bone. Skin and bone. And that globular, it is found in hemoglobin, insulin, and enzymes. Okay. Talk about the solubility in water, soluble or not. So fibrous are insoluble. So hairs are made by the keratin protein, and you know hairs are insoluble, and these are soluble. Next point, role. What is the role? They played role in the structural like collagen in bone and cartilage, keratin. Again, keratin is spelling mistake. Huh? Keratin in fingernail and hair, and this globular in metabolic process like enzyme in all organism, plasma protein, antibodies in mammals. So this is the molecular shape of protein, children, according to the what you can say, according to the shape, two type, fibrous and globular. So let's check the structure. I'm not very good in trying, but I will try here. So this is the fiber protein, okay, fibrous protein. Globular, if we are talking, so it's a this kind of structure for globular protein. Okay, so this is the simple structure, fibrous and globular. Not simple, it's a difficult. Okay, so but this is for this is the for fibrous and this is for globular. If we are talking about the structure of protein, children, what we are talking, structure of protein. So in that case, what happened? 1 minute. Structure of protein. So what is the classification? The structure and shape of protein can be studied at four different levels. So what we are having, four different level. What I am saying, structure of protein can be studied at four different level. What are the four different level? Primary structure of protein, secondary, tertiary, and quaternary. So four different level of protein structure: primary, secondary, tertiary, and quaternary we are having. Each each subsequent label being more complex than the previous. What it is written here, each subsequent label being more complex than previous. So more complex will be quaternary, then less third quaternary, then secondary, and this is the primary. Okay, so primary structure of protein. What is the primary structure of protein? Primary structure of protein, that means it describe the sequence of amino acid connected together to form the polypeptide. What is written here? It describes the, see children, don't lose your patience, it's a theoretical portion, so little bit boring also, but if you will pay attention then things will be easy. It describes the sequence of amino acid connected together to form the polypeptide. Okay, so check the structure. I'm saying I'm not good in drawing, but I will try for you. Suppose here leucine A, then valine V. So here C serine, then again valine, then propyline, then again serine, and then again leucine. So these are not the symbol, children. A B C D link I make. If you want to write the name, then I can write for you. It's a leucine, then valine, then serine, then again valine, then again proline, then serine, SCRINE, again leucine, like that. So here, children, these are the amino acid, these are the amino acid, and they are connected with polypeptide bond. They are connected with polypeptide bond. These are the bond. Okay, so this is the primary structure. Okay, so in the case of insulin, children, what happened, the same time I am telling you. In the case of insulin, cytine, what pronounce you can Cystine, is used to form disulfide, disulfide. Okay, in the case of insulin, two chains are there. Chain A, 21 amino acid, and chain B, 30 amino acid connected. Okay, so that is not important, that's why I'm not writing the complete structure of insulin. So this is the primary structure. Okay, primary. Now come to the secondary. In the case of secondary, it describes the shape in which polypeptide chain can exist. Okay, so two type in that case they can exist. One is alpha helix, it's a helix structure, and second is beta pleated sheet. Okay, so helix means what, children? It's like this is the helix. Okay, so structure for these, I'm not going to draw. There is a structure of beta pleated sheet, this one, and sorry, this is beta pleated sheet, correct, and this is alpha helix, okay. So this is your alpha helix, this is the alpha helix case. I hope it is clear. You can go through the NCRT also, there it is also available. Then beta pleated sheet and alpha helix structure we have discussed. What are the important things? Alpha helix. In alpha helix, all possible hydrogen bond all possible hydrogen bonds are formed to give right right-handed screw. In physics, you know right-handed screw same, so it gives right-handed screw configuration. Okay. In beta pleated sheet, structures beta pleated structure the peptide chain are stretched out to maximum extension to maximum extension and then joined by intermolecular hydrogen bond. Okay, so this is about the primary and secondary, children, that we have completed. Definitions are there, go through it once. What is written here, focus on it once. What is written here, alpha helix, all the possible hydrogen bond are formed to give right-handed screw configuration. Beta pleated sheet peptide chain are staged out to maximum extension and then joined by intermolecular hydrogen bonds. Now tertiary, number 3, tertiary. The ring in the tertiary structure, it is just like in between this, so here this is your iron atom, and here this secondary, and this complete is tertiary, and it's a hemoglobin actually. So what is the points? The ring surrounding iron atom is called Popperin system. Porphyrin. But it's called Popperin system. The secondary structure protein is bounded. The secondary structure protein is bounded. This is all. So hemoglobin structure. See, the thing is, if you have quaternary structure, then when you will unfold, then you will get tertiary. Then if you will unfold tertiary, then you will get secondary. If you unfold secondary, then you will get primary. It is just like that, unfolding matter. Last, number 4, quaternary structure on joining multiple tertiary structure on joining multiple tertiary structure, we get quaternary structure. On joining tertiary structure, we get quaternary structure. Okay. Here you can write quaternary structure is like conformation of tertiary structure. So in human insulin, human insulin is a hexamer, and hemoglobin is a tetramer. Okay, so in that case, see that time I told you right-handed screw. So that is the right-handed screw. You can check it, right-handed screw, and this is the structure, and this is the beta plated seat. Okay, and these are the primary structure. This is the primary, and here secondary protein structure, alpha helix, beta plated seat. This is tertiary protein structure, and this is the quaternary. So these are the structures, children. Okay, so few definitions, and this protein will be finished. Subunit. Subunits. Some proteins are composed of two or more polypeptide chain called subunit. Some proteins are composed of two or more polypeptide chains and called subunits. Okay, so this is all about the protein. One last topic of the protein is denaturation, and we will finish. Denaturation of protein. What is the meaning of denaturation, children? It's very simple. Denaturation, according to the word, natural shape or system destroyed. They will lose their natural shape or biological system, that is denaturation. So if we are talking about definition, then I am writing here. It's again a theoretical part. So be with me. It is a process in which in which proteins or nucleic acid, they also proteins or nucleic acid lose the quaternary structure, tertiary structure, and secondary structure, which present in their native state. So think about it. It is a process in which proteins or nucleic acid lose the quaternary structure, tertiary structure, and secondary structure which present in the native state. Why it is happening? It is due to external stress or compound such as strong acid or base or concentrated inorganic salt an organic solvent radiation or heat. If protein if protein in a living cell denatured this result disruption of cell activity and possibly cell death. So once again check it guys. It is due to external stress or compound such as strong acid or base, concentrated inorganic salt, organic solvent, radiation or heat. If, if protein in a living cell denatured, this result disruption of cell activity and possibly cell die. So this is the denaturation. So that is the definition part. Hope it is clear to you. You can take the screenshot or whatever. Next. Next is native protein. What is native protein? Protein found in a biological system biological system with unique 3D structure and biological activity. Okay, so that is the native protein. So reason for denaturation once Physical change, like change in temperature. Chemical change, like change in pH. Okay, so thank you guys. This is all about the protein. It's a long lecture, but finally we have completed the protein. And next video based upon the nucleic acid. Same time again it is important. Then we will finish one or two lecture maximum. Two lecture we will wind up the topic. Thank you guys. Please watch the video, share the video. All the best.